Alright, well, we did Hawkeye TV. My name is Pasquale D'Agostino.
My name is Diane Benitez.
And I am James Couch.
And our sponsor for this project was John Cool. And our motivation and goals behind this project were to basically, smart TVs are really awesome, but you might already have like a big screen TV and you don't want to spend extra cash to get a smart TV. And so what we wanted to do is we wanted to create a portable device that could make your dumb TV into a smart TV. And there's other products out on the market, but they're a lot more expensive. So one of our major goals was to make sure that it was cheap. And then we also wanted to implement a web-based service because web-based services are a lot more dynamic and we can create a nice, beautiful GUI a lot faster than going through a more traditional method of a desktop application. And then we wanted to also have like a modular design because we wanted to have future growth for the application. And then our basic prototypes for the for our smart TV was that we wanted to have YouTube streaming, music streaming. We wanted to have basic settings that you can set, like your location. So we have a weather and time widgets, and we also have social media aspects as well as an RSS feed.
Okay, so my part was the hardware, and we basically I developed a power supply for the Raspberry Pi with a battery backup. The Raspberry Pi needs 5 volts plus or minus 5%. So it could go from 4.75 volts to 5.25 volts. The average that the Raspberry Pi takes, it's between 500 to 750 milliamps, depending on what's functioning on the Raspberry Pi. The power supply that I built was able to provide up to 1 amp, and all of the devices the components that I put on the circuit were good for 1 amp. And to protect the circuit, I used just the fuses. And one decision that I had to make was to whether use just the regular regulator, the voltage regulators, which is the 7805, I believe, or the DC to DC, or another type to bring down the voltage. And I used the DC to DC so the regular regulators, or like the common regulators, usually heats up too much. So using this device, I didn't have to use a heatsink or anything else to cool it off. On the next slide, I show the schematics for the power supply, and it's basically what I have. It's basically the transformer, which brings down the voltage from the 120 to 12 volts. Then a bridge rectifier. Then when I get the DC, then I just connect which is called the Traco power, that's the DC to DC converter, and that basically just brings down the voltage to the 5 volts. Now I have 2 different schematics just because I connected the rechargeable battery. The second one is just showing connecting the rechargeable battery to the circuit, but now this is showing how I connected the rechargeable battery, which is you just connect it through the USB, and it has 4 ports. The first port or pin is just 45 volts. The last one, which is the 4th port, is the ground, and then it has 2 data pins, which they needed 2 volts also to recharge the battery. So that's what I'm showing there, and this is just showing when it goes to the battery, and then the battery provides the 5 volts, and it does provide provides up to 750 milliamps.
So a little bit about our physical server. We use the Raspberry Pi because it's a $35 all-in-one computer. It is using the ARM architecture CPU, and it's 700 megahertz. And then we have a little under a gig at just half a gig of RAM. And then the real interesting thing about the Raspberry Pi is that it has a dual-core video core 4, which is an actual very powerful GPU for how big this device is. If you've never used a Raspberry Pi before, it's about the size of a credit card and no taller than a quarter. So to have an all-in-one computer, that's pretty impressive. And so some of the reasons why we chose this is because it has street cred, in the hacking and prototyping world, so we knew that we would be able to use this for our rapid prototyping methods. It's cheap and powerful enough to meet our requirements, and there's a large community for this device, so we knew that we'd be able to find any libraries or modules that we may need, as well as help out on the internet. And then to talk more about our software server side, we use Node.js, which is a JavaScript software platform, and the benefits of it is that it's fast and scalable for network applications, and it's lightweight and efficient. And what I mean by this is that it uses a single thread, and that is very lightweight and efficient in the sense that in other frameworks you may have multiple processes, and they have, if you think of a process, there's small chunks where you're actually doing processing and there's times where you're waiting. So the whole point of Node.js is that it lives to make sure that you're waiting as least as possible. So we knew that this would be very helpful for the Raspberry Pi constraints because it would utilize very little CPU and memory, which the additional memory we could put onto the GPU for processing. And another interesting fact is that it's JavaScript. So it's JavaScript on the server side and it's JavaScript on the client side. So, and with that, it's also built off Chrome's V8 JavaScript engine, which is comparable to, they're saying it can almost match most compiled languages, so it has the speed. And so for its role in our application is that it's the base of our application. It's not necessarily a web framework. We use Express.js, which is our web framework, but we have our built-in, we have a small API for storing our persistent data, and it also acts as our man in the middle for handling our relay requests, which James will go in later about how we use Socket.io in order to communicate with the remote app and the TV app. And then we also have this forever server, which pretty much limits our downtime because it monitors the application and checks to see if it ever goes down. And if it does go down, it restarts the server and makes sure that we have limited downtime. And the neat thing with the JavaScript on the client side is it'll still render and act on the client side because it's all loaded in the client's browser. So it also limits our downtime in that factor because the user can still use the application without any noticeable issues.
Right, so in the client side, we use a technology called Backbone.js, and this is a client-side framework, which is a model view model type of framework. So when we talk about views, we kind of are saying like YouTube is a view, Facebook is a view, Twitter is a view, Spotify and RSS, those are all views. So what this means is our system is very modular and it's very adaptive. So let's say down the line we wanted to add a Netflix type of functionality or another sub-application for this application. We would easily be able to add just one file to the Raspberry Pi stored on the SD card, and then it would easily hook into the home view. And then so when you choose a view with your remote, which is the phone, let's say you choose Twitter view, all these other views they will hide, and then just your Twitter feed will show up. And the same goes for Facebook and Spotify, RSS, and YouTube. So it's very scalable, and it allows you to have a lot of different functionality and with your views. In addition, we also have time view and a forecast view, which you'll see in the next slide. It actually has a screenshot of our system. So this is kind of the front end of it. As you can see up top, we have the TV, and then we have our remote. The remote is your cell phone, and it's you're connected over the same Wi-Fi access point, and you enter in the IP address of the Raspberry Pi. And when you do that with your phone, the client-side Backbone.js JavaScript, it notifies, okay, this is a phone. Let me render the cell phone view, the remote view, and then if you're on the TV, it says, okay, I will render the TV view. So one great technology we used in this software was it's called Socket.io, and in traditional web applications in today's world, it's something called long polling, and what that is let's say you're on a website and you need to get something from the server. What you'd have to do is check every 1 second or 100 milliseconds to see, oh, did something change on the server? But with this Socket.io technology, it means that we're able to directly push data from the server to the client. So rather than having our TV ask the server every second, oh, did the person press the button? Do they want to watch a YouTube video? Do they want to do this? We're able to tell the TV that we want to do this action. So we're able to tell the TV, perform this action. We're able to tell tell the remote that we click this button or render this view, and so that allows us for really direct communication between the client and the server and the remote. In addition to the Socket I/O functionality, we also allow for other customization of the software. So within the remote, you have this settings button, and when you click the settings, a drop down shows up, and you're able to log in and log out of Facebook. You're able to change the zip code. So the weather up top, the forecast view changes and gives you the forecast for that that zip code. And in addition, you're also able to change the background. So we have 3 backgrounds right now. We have a mountain view, the default view, and then a University of Iowa view. So change the background and change the styling up a little bit. And in addition, in general, you're able to pretty much control every single thing from the TV from your cell phone, and multiple cell phones can control it, and it really allows for a fluid and functional user experience for the smart TV.
Any questions?